Hello guys, welcome back. This is another video on GATE previous year questions, and this time we are seeing a question on network theory from GATE EC 2021. So the question itself looks very big. Let us see how we proceed. So the circuit shown in the figure contains a current source driving a load having an inductor and a resistor in series with a shunt capacitor across the load. The ammeter is assumed to have zero resistance. The switch is closed at time t equal to 0, and they have given the circuit, and here they are driving the circuit with a 1 ampere current source, and the switch is closing at t equal to 0. And here is the ammeter. So what it is measuring? It is measuring the current in this arm, which is nothing but the current through your inductor. Okay. Initially, when the switch is open, the capacitor is discharged and the ammeter reads 0 ampere. So what it means? Your VC of 0 is equal to 0 volt, and ammeter is 0 ampere means your IL of 0 is 0 ampere. And after the switch is closed, the ammeter reading keeps fluctuating for some time till it settles to a final steady value. So what will be that final steady value if we can find? So in the steady state, the cap will be open, the inductor will be short. So this 1 ampere will entirely flow through the ammeter, and we'll get a 1 ampere reading in steady state. Okay. So we'll mark it here 1 ampere. The maximum ammeter reading that one will observe after the switch is closed, rounded off to 2 decimal places, is dash ampere. So we know that starting value the ammeter is 0 ampere and finally it reaches 1 ampere, right? So let's say this is the ammeter reading. Initially at t equal to 0, it is 0, and at some infinite time it reaches 1 ampere. But we don't know what is happening in between. So if you observe this, if it is a first order system, how will the settling be? So it will just be an exponential response. It will never cross 1 ampere mark. So I'll call it first order. It means that it has only one pole. Now if it is a second order system, in second order system only we have 3 types. So for second order system, we can have an underdamped response. Right? In this case, what happens? It will shoot above that 1 ampere mark and then finally settle to that 1 ampere, right? So in this case, our answer cannot be 1 ampere. It should be more than 1 ampere. Okay. The second is critically damped. So in this case, what happens? Here also it never crosses above 1 volt, right? So here, sorry, it is 1 ampere. So it never crosses 1 ampere. So here also our answer, if it is critically damped system, and if it is a second order and critically damped, it will be 1 ampere. Similarly, the over damped also, it never will cross my 1 ampere mark. Here it will be even slow, but it will never cross my 1 ampere mark. It will finally settle to 1 ampere. So in both these cases, my answer will be 1 ampere. But if it is underdamped, then I have to figure it out. So now let us actually calculate what type of a system this is. Okay. So basically, I want to find my this current IL by IN. So IL by IN is nothing but the impedance in this divided by the total impedance. So 1 over SC, I'll call it as 1 over SC, SL and R to start with. And I have SL plus R plus 1 over SC. So this is nothing but 1 by S square LC plus SCR plus 1. And I can write it as 1 by LC by S square plus SR by L plus 1 by LC. So this is of the form of omega n square by S square plus 2 zeta omega n plus omega n square. This is a second order system, right? So now let us find each of the parameters. My omega n is nothing but 1 over root LC. So which is nothing but 1 over root of, my L is 10 into 10 power minus 3. So 10 power minus 2 into my C is 100 into 10 power minus 12. So 10 power minus 10. So this will be root of 10 power minus 12, which is 10 power 6. So then my zeta, so 2 zeta omega n is R by L, right? And my zeta will be nothing but 1 over 2 R by L into 1 by omega n, right? Which is nothing but root LC. So this is 1 over 2 R root of C by L. So this, if we calculate, what it comes to, 1 by 2 into, my R is 5k. So 5k root of C is 10 power minus 10 by 10 power minus 2. So this is nothing but 10 power minus 8. So if I take a root, it will come to 10 power minus 4. So this into k will be 10 power minus 1, and 5 by 2 is 2.5. So this will be 0.25. My zeta is 0.25. And if you remember, for a second order system, if your zeta is less than 1, then the system is underdamped, right? If zeta is equal to 1, it is critically damped, and greater than 1, it is overdamped. So this makes our analysis even complex. So if you're well prepared for the GATE exam, you should have already done this analysis beforehand, before the examination hall. And you should actually remember few of those formulas, such as the maximum overshoot, or at least where it occurs. Okay. So for now, I'll assume that you're new to it, and hence we'll go ahead with the calculations. So I will take a, so IL by IN, we had it as omega n square by I'll keep it as omega and zeta so that we'll get a general expression. So even if they give some other questions, you will be able to solve it just by using the formula. Only thing is you have to remember the formula. But this analysis also helps you in remembering the formula. Okay. So 2 zeta omega n s plus omega n square. Okay. So here I forgot an s. I'm adding it. Okay. So now, and in here what it is nothing but it is like a step, right? Because before t equal to 0, it was 0. And only when the switch closes, this 1 ampere is coming. So it is like a step. So in Laplace domain, what is a step? So it is just 1 by s. So your IL is nothing but I in into this. So it's 1 by s into omega n square by s square plus 2 zeta omega ns plus omega n square. So now how you want to get a transient response, something like this, right? How will you go from Laplace to transient? You have to take your inverse Laplace transform. So to take inverse Laplace transform, you have to perform some operation, bring these coefficients to known form and then take it. So what are our known forms if you remember? So cos omega t e power minus at u of t. This has a Laplace transform of s plus a by s plus a square plus omega square. Similarly, sin omega t e power minus at u of t. This has a Laplace transform of omega by s plus a whole square plus omega square. So if this was a overdamped system, we could have written down, we would have got two poles for this, right? Two real poles. So we could have easily written this as s plus a into s plus b. And then we could have done a partial fraction method and we would have got this u of t and some e power minus at u of t terms and e power minus bt u of t terms. But since it is a underdamped system, if you try to take it in this form, you will observe that your a and b will be complex poles, right? So you don't have any direct inverse Laplace transform for complex poles. So you have to go with this method only. So let us move further and see how we bring it to this form. So let us first separate this s and this remaining term. So I'll write it as s and here I'll write it s square plus 2 zeta omega ns plus omega n square. So when I do the operation, finally I should get omega n square, right? So then what I will do, I will just try to cancel these terms. So I'll put a minus sign here. Here I'll put 1. So if I cross multiply, I'll get all these terms. I want to cancel these. Omega n square I want to retain. So to cancel this, I have to add s into s square plus 2 zeta omega n. So if you cross multiply, you will just get omega n square at the top. Okay. So now 1 by s we already know inverse Laplace transform is u of t. So now we need to simplify this part to something like this. So how we'll do it? So let us only consider the denominator now. So we have s square plus 2 zeta omega n s plus omega n square. So now I'll write it as s square plus 2 into, we have s here. So s into zeta omega n. And then I'll add and subtract zeta square omega n square, zeta square omega n square. And I have omega n square left. So now if I observe this part, it is nothing but s plus zeta omega n whole square, right? And this part, if I combinely write, this is omega n square plus omega n square root of 1 minus zeta square. So this zeta itself is less than 1. So your 1 minus zeta square is greater than 1. So root is anyway going to give you a real number. And this total part is real. So now if you observe, you would have got in this form, the denominator. So now numerator also we have to convert into this form. So we have s plus 2 zeta omega n by s plus zeta omega n whole square plus omega n square root of 1 minus zeta square. So for now, I'll just call this as omega d square because this is going to be repeating. Again, I'm sorry, this root still hasn't come, right? If you have to take a root, I have to put a whole square. Okay. Okay, I'll do that only. So this is omega n into root of this in whole square. Okay. This is whole square. So this I'll call it as omega d. So what is my omega d? It is omega n root of 1 minus zeta square. Okay. So now I am having it in this form. So if I observe, if I want a cos form, I need s plus a. So here a is nothing but zeta omega n. So I can just separate this out. I can write this as s plus zeta omega n plus zeta omega n. And then I'll write s plus zeta omega n by this one. S plus zeta omega n whole square plus omega d square. And similarly, I'll have another zeta omega n divided by s plus zeta omega n whole square plus omega d square. So for sine, what I need omega at the top. Here omega is omega d. I need a omega d here, but I have zeta omega n. What I will do, I will just take this. I'll multiply and divide by omega d. Okay. And what happens to this? This is nothing but zeta by root of 1 minus zeta square. Okay. So now this is of my sine form. This is of my cos form. So if I go back here, I have 1 by s minus of this term, right? So my IL of t will now become 1 by s will become u of t minus this term itself become cos of omega dt e power minus a. A is here zeta omega n t, right? U of t minus of this factor is there, zeta by root of 1 minus zeta square sine of omega dt e power minus zeta omega n t. So this is your transient response for an underdamped system. So every time you cannot keep deriving these, right? In exam hall, you cannot keep deriving this. So one thing to remember is, if you observe, your omega d is nothing but omega n root of 1 minus zeta square. This you can remember. This is the frequency of your sinusoids. It is gonna be at a factor of omega n into root of 1 minus your damping factor square. And your exponential time constant, tau, is nothing but 1 over zeta omega n. So these two you can easily remember, right? Okay, now what is our target? We need to find the maximum overshoot, right? The maximum value. So for finding maximum values, what we have to do? We have to take derivative of this and equate to 0. So my IL of t, I'll rewrite again in an easier form. Just 1 minus cos omega dt plus zeta by root of 1 minus zeta square sin omega dt into e power minus zeta omega nt into u of t. Now I want a maximum of this term. So I'll take d by dt of this equal to 0. So d by dt of 1 is 0 minus d by dt of this term. What I have to do? I have to do, this is like a into b form, right? So I have to do dA by dt into b plus a into db by dt, uv form. So if I do dA first, I'll get omega d into cos omega dt, derivative is minus sine. So minus sine omega dt plus, here it is cos only, I'll have omega d extra divided by root of 1 minus zeta square. So here it will be cos omega dt and I'll have e power minus zeta omega nt, right? And the next thing, I'll keep this same. So minus cos of omega dt plus zeta by root of 1 minus zeta square sine of omega dt into derivative of this. Derivative of e power minus at is minus a e power minus at. So I'll get a minus zeta omega n e power minus zeta omega nt equal to 0. So this omega nt is common. I can take it that side and it will vanish. And this is anyway 0. So if I try to combine the sine and cos terms, what I will get? I'll first try to combine sine omega dt term. So here what I have plus omega d, right? And here what I have, minus zeta square omega n by root of 1 minus zeta square. So this minus or plus, we have two minus here, so it becomes plus. And I'll combine my cos terms. So plus cos omega dt into, I have minus here, minus zeta omega d by root of 1 minus zeta square. And here also I have plus zeta omega n equal to 0. Now omega d itself is nothing but omega n root of 1 minus zeta square. So this term is nothing but minus zeta omega n, right? And I have here plus zeta omega n. So this cancels. So my cos term totally vanishes. So I have only my sine term. So sine omega dt into, can this term go to 0? No, right? This term is a non-zero quantity. So this is equal to 0. What it means? Only my sine omega dt should be equal to 0, which means that my omega dt is equal to n into pi, right? Whenever this is integer multiple of pi, then sine goes to 0. So what it means? And my n is equal to 0, 1, 2 and so on. So my t is n pi by omega d and my n is 0, 1, 2 and so on. So what it means? I don't have a single maxima or minima, but I have multiple maxima minima. Why is that the case? Because if you see the underdamped response, you have something like this, overshoot, then the undershoot, then little lesser overshoot, undershoot and so on. This is going to continue till infinity, till it dies down, right? So then what happens? That is why this n is coming. Now what else can you observe? Where does the maxima and minima occur? It is at the integer multiple of 1 by omega d or pi by omega d. And omega d, what did we say? It is nothing but the frequency of our sinusoidals which we got from the transient response. So we needn't even have done all this if we can just remember our maxima and minima are going to occur at pi by omega d, integer multiples of pi by omega d, right? Okay. So where does our first maxima occur? It is at pi by omega d. The second is going to be a minima, which will be occurring at 2 pi by omega d. So now let us try take our IL equation. Okay. Now we know where our maxima is occurring, first maxima is occurring, or the maximum value of the entire waveform is occurring, which is the first maxima. But I don't want that information. What they're asking in the question is, what is that value of maxima? So I have to substitute the t in this and get the maximum value. So IL max is equal to, this is nothing but this, anyway we simplified previously only. I think here is a simplified equation. Anyway, we'll continue with this. 1 minus cos, here it is pi by omega d. So t equal to pi by omega d. So it will be cos pi e power minus zeta omega n pi by omega d, right? Minus zeta by root of 1 minus zeta square. And if you observe, this will be sine pi, right? Into some e power the same term. Okay. And sine pi anyway is 0. So this is going to go to 0. So this into u of t, and then we are concerned with t greater than 0. So I can remove this. So this comes to be 1 minus cos pi is minus 1 e power minus zeta omega n pi by omega d. My omega d is omega n root of 1 minus zeta square, right? So this is 1 plus e power minus zeta pi by root of 1 minus zeta square. So this is your final expression, IL max. So if you recall, in some of everywhere they'll only mention this term. They'll call it as peak overshoot or max overshoot. Overshoot value is, it is how much above the final steady state value. So it will be 1 minus this value, which will just be, sorry, this value minus 1, which will just be e power minus zeta pi by, or pi zeta by root of 1 minus zeta square. So this is what they'll tell you everywhere. They will never go through this entire derivation, and you will also be reluctant not go through. You will try to remember the formula, right? But now you can easily remember the formula, right? So just based on whatever I have said you. So you need to remember few easy steps, whatever I told you, right? So you know the time constant tau is easy to remember. So it is just 1 by zeta omega d for a second order system, omega n, sorry. And what is the other thing we said? Your sinusoidal frequencies are occurring at omega d, which is omega n root of 1 minus zeta square. And your max and min occurring are similar to where your nulls of sine occur. Sine function, right? Sine omega dt occur. So which is nothing but t equal to n pi by omega d. And you know your transient response itself looks something like 1 minus cos into this omega dt e power minus t by tau minus some term. Let's say you forgot the term also. You need to remember that. Sine omega dt e power minus t by tau into u of t. This is your transient response. So even this transient response, right? In many textbooks and websites, they will give to you it as 1 minus some, let's say some factor beta, and they will write it as sine of omega dt plus theta, and e power minus some t by tau, this t by tau. This doesn't give you any intuition. This is like more easier to understand. So now what happens at our nulls? Your sine term goes to 0, so you needn't worry about this alpha factor. And what happens to your cos? If you see your cos omega dt, your t is equal to n pi, so you will get cos n pi, which is going to be equal to minus 1 whole power n. So for odd values, which is the peaks, it will be minus 1, and for even values, which is the trough, the minimum, wherever the minima occurs, it will be plus 1. So here itself it will be for maximas, it will be 1 plus and 1 minus for the minimas. So here we want 1 plus for the n equal to 1. And then we have e power, this is anyway 1, minus t by tau. Tau is nothing but 1 by zeta omega n. So this is zeta omega n, and your t is pi by omega d into pi by omega d. And you know your omega d is omega n root of 1 minus zeta square. So you can easily get e power minus zeta by root of 1 minus zeta square into pi. Let's say they're asking you for the first minima. How will you find? You just need to take n equal to 2. So what will be n equal to 2 here? This pi will just become 2 pi. So what will this become? This will be 1 minus, because it is a minima, and your cos is cos is 1, so this minus will remain intact. So I'll have e power minus 2 pi zeta by root of 1 minus zeta square. And for nth pulse, you will have n and minus 1 whole power n here, right? So if you see, as n increases, your this e power value goes on decreasing, and your final steady state, it is getting close and close to 1, and finally at t equal to infinity, it will become 1. Okay. So this is the all thing that you need to know with respect to the transient response of a second order system. So given this equation, you can find whatever they're asking for. Okay. So now what they're asking, we'll come to the actual question. So they just want the maximum ammeter reading, and this is an underdamped system. What is the zeta? Omega and zeta we calculated. Zeta is 0.25, or omega n is, if we have it is 10 power 6. So for this calculation, we don't need omega n. It is just dependent on zeta. So it is 1 plus e power minus pi zeta by root of 1 minus zeta square. So zeta is 0.25. So if you calculate this, so it should be minus pi 0.25 by root of 1 minus 0.25 whole square. So let us calculate this using a calculator, and this comes out to be 0.444. So this 1 plus 0.444, which is 1.444 ampere. So this is your peak current, max current this circuit takes, and they're asking us to round it off to 2 decimal places. So we'll reach 1.44 ampere.